Good morning, everyone. In today's session, we are going to continue with chapter number 9, object oriented testing. So, these are the contents from the chapter number 9. From that, we have seen object oriented testing strategies. And in today's session, we are going to wind up with the test case design for object oriented software and interclass test case design. Here, we are starting with the class testing. Here class testing is same as module testing, module or component testing. We are going to test the module. Module wise we are going to test here, or we are going to test the component of the system. So here each separate class with its instance is tested. We are going to test each class separately, and we are going to test that class with their instances. So here also we are going to test all the types of methods, all types of methods encapsulated in each class, that are private and public methods. We are going to test all these methods from the class. Here you can see the figure of that unit testing on classes here. Suppose this is class is having multiple methods here, like method 1, method 2 and method 3. So we are going to test all these methods from this class. So your class testing is the first level of integration testing, which tests the individual classes. In class testing, each method is tested and the state behavior of the class between that method is also tested. We are going to test the all the methods from that class. Then there are some challenges or issues of class testing is there, like encapsulation, inheritance, polymorphism. Okay, so here first one is encapsulation. Here it is difficult to test a class without knowing the state of the classes. Without knowing the state of that particular class, it is difficult to test that class. So and this can be known only by using the methods. So we are going to know that which the state of the class by methods from that class. Then the inheritance. So here in inheritance, each base class and their derived classes need to be completely tested. We have to test, or it is necessary that each base class and their derived classes should be tested completely. So the level and the order in which this base class and the derived classes are tested is also a challenge. In which order we have to test that base class and that derived class. It is a challenging thing in that class testing. So order of classes can be complex thing. Is here order of classes that are we are going to test here, that is complex thing. Here you can see by using this figure there are number of classes are here, like class screen. You can see here class screen, class card slot, class security, class bank, class number keyword keypad. So it contains several methods like show message, validate the card, check pin, pin for pan, and get key events and parse key events. So the the order of that classes can be complex here. That first here you can see the start, that customer has to insert the card, then it validate the card, then check the pin, then get key events and show the messages. So order of that classes or that methods that we are going to test is the complex thing in the class testing here. Then next one is the polymorphism. Here polymorphism in this class testing, there each child class requires retesting. Each child class requires retesting because some methods in them may be implemented differently under polymorphism. When we are talking about polymorphism, each class test or each child class requires retesting because some methods from that class are implemented differently under the polymorphism. So like a method may be implemented by more than one class, one method is implemented by more than one class, or the type or the number of arguments differ for the same method. That is overloading, that one method is having different parameters in different classes. Okay, so here how that polymorphism can be complex thing. Here you can see in this figure how that polymorphism is complex thing in the class testing. Here you can see the method 1 for class A, method 1 and method 2 is there. So this method is implemented, or method with the different arguments is same method name and different arguments, that is overloading, method overloading, that multiple classes uses the same method with the different arguments. Okay, that is polymorphism, or that is method overloading issue. Okay, then next type of testing is inheritance testing. Here, inheritance testing, here we have to test the assessor methods before creator methods. That methods we are going to access, that we have to test first, and before the creator methods we have to test that assessor method, so as to control the complexity of, like whenever we are adding new methods, inherited methods and redefined methods. So here new methods means these methods are defined in the child class. New methods are defined in the child class and not inherited or overloaded by methods of or methods in a superclass. These new methods are defined in the child class and not inherited or overloaded by methods in a superclass. So testing the new methods is known as complete testing. Then second is inherited methods. So these methods are defined in a superclass of child class that is under test here. So inherited methods are defined in superclass of the child class and that are under test here. So testing that inherited methods is known as retest. Only if the methods interact with the new methods. Here, testing that inherited method is known as retest. And third one is redefined methods. Redefined methods. So here, these methods are defined in superclass of the child class, but again redefined in this child class under the test. So this type of testing is known as complete retest. Redefining means we are going to completely retesting that and reuses the test from the superclass. So that's all about inheritance testing. That are we have to test the assessor method before the creator methods to complete to control that complexity. Complexity regarding new methods and inherited methods and redefined methods. And next type of testing is state transition testing. So here in state transition testing, so this test the different state and transitions of a class. Here the state of an object is the combination of all attributes, values and objects. Here state of an object is the combination of all attribute values and the objects. An object may transition from one state to another state as a result of some event which may yield an action. An event means action. We have seen the state transition diagram that we are having some state and we are having some transitions, we are performing some event, and based on that event we are going to perform some actions. The transition means transition from one state to another state. So here test cases are created to test each transition path and the different state of the class. Then here it includes the transaction flow testing and exception testing. So here transaction flow testing, we have to test the flow of messages and data from one instance of a class to another instance. That is transaction flow testing. We have to test the transaction, or we have to test the flow of messages between flow of messages and data from one instance of class to another instance of class. And second one is exception testing. So here this test every array subscript reference, every memory locations or every memory allocations. That is exception testing. Here that is state transition testing. We have to test the different states and transitions of a class. And next type of testing is integration or the cluster testing. Here it is exactly opposite test of a unit testing. Integration testing is exactly opposite of a unit testing. In unit testing, we are going to test the components separately. But in integration testing, we are going to integrate multiple modules and we are going to test that modules together. Here in this test, at least two modules are primarily integrated and tested. That means we are going to integrate the modules and we are going to test that modules together. So there are some types of integration testings. So first one is big bang testing, then top down testing, bottom up testing and sandwich test. So yeah, first one is big bang testing. So in this testing, all smallest component in the product are tested. The smallest component of the product are tested in big bang testing, that are tested individually. Then that are combined together and test the combinational work of the system. Here, generally the test how one component is support to the other component in working. That is Big Bang testing. We are going to test all the smallest component of the product that are tested individually, and then after testing we are going to combine that. Then next one is top-down testing. In top-down testing, this approach is about breaking down a system into compositional subsystem. In top-down testing, we are going to break the system into a compositional subsystem. So here each subsystem is tested is greater detail until the entire system is reduced to the base units. So here the importance of this top-down testing is to design flow is tested. Design flow is tested in top-down testing. Then quality improves, user satisfaction, requirement matches with the developed software, and user view or the user's primary view of the system. Then the secondary view of the system, that is top-down testing. Here, then third one is bottom-up testing. Here, bottom-up testing, this is exactly opposite of the top-down testing. Here, since that component at the bottom level is tested first. In top-down, we are going, the flow is from the top to down. And bottom-up, that bottom level or the component at the bottom level, we are going to test that first. And after that, we are going to test the lower level components that are integrated with the above components, and then combined testing is done. That is bottom up testing. And fourth one is sandwich test. So this is the combination test of the top down and bottom up testing. That is sandwich test, combination of top down and bottom up testing. So that is, these are the types of integration testing. Then next part is stubs. So a stub means if two units are supposed to interact with each other and only one unit has been developed, then a template of other unit can be developed just to test the interactions, and this template is called as stub. Yeah, we are that if two units are supposed to interact with each other, we are having two units and we are going, and suppose we are going to interact with, or that two units are going to interact with each other, and only one unit from the two units has been developed, and then a template of the other unit can be developed. Here that means we are going to develop one unit and we are going to use the template for the other another unit. So we have to test that interactions, and here uh, test that interaction and this template for the another unit we have created, that is called as stub. So advantage of this is a developer of the first unit need not wait until the second unit is developed. So developer does not has to wait for the implementation of second unit, and he simply uses the stuff of second unit to get his work done. If we have developed, if we have to develop two units and we have developed one unit, then developer will create the stub of second unit. It does they does not have to wait for the implementation of second unit. He simply created the stub of second unit and complete his task. That is the advantage of the stubs. And what is the disadvantage of this? Your testing must be repeated again when the actual second unit is ready. After implementation of the second unit, the testing has to be repeated. We have to read. We have to again. We have to repeat the test while that second unit is ready for the testing. That is stub. Then next type of testing is acceptance test. Here, acceptance testing is a testing technique performed to determine whether or not the software system has met the requirement specification. Whenever we are going to create any, or we are going to develop any software application, we are having some requirements, having some requirement specification, we are having requirement document. Then after at the end of that testing, that is acceptance testing, we are going to match the actual implementation with the requirement that we have, that requirements we have specified are matched with the output that we are getting. That is acceptance testing. That means here that software system has met the requirement specifications or not. Here the main purpose of this test is to evaluate the system's compliance with the business requirements and verify if it has met the required criteria for delivery to the end users or not. We have to match the criteria that users that match the criteria for the delivery to the end users, that based on the requirements that system is going to perform or not. Then there are several types of acceptance testing, that is configuration review, alpha testing, beta testing, and user satisfaction test. So here configuration review means according to this review, we ensure the software configuration. Configuration review means we have to ensure about the software configuration. That is hardware requirement, software requirement, platforms. Okay. Then second one is alpha testing. So here this alpha testing, this test done at the developer side in consideration of the user's requirement, environmental parameters are also considered in this testing. In alpha testing, we are going that testing is done at developer side. It's about user requirements, environmental parameters, and alpha testing is done when development is nearing to combination so as to find if any minor decision changes are still required to be made or it is okay. If we are having any minor changes in the application that we have completed that minor changes or not, the testing is regarding to that. Then next one is beta testing. So this test is done at the customer side in live environment, that is realistic workout. So it is called as live testing. Unlike alpha testing, the developer is not present in beta testing. Beta testing is done at the customer side, that is live testing. Here the end user documents all errors that comes across during the beta testing and submits the report to the developer at regular intervals. After beta testing, that if that customer is having some errors with the system, he make a one documents of all the errors and submit that report to the developer. Okay, then developer make the modification and then start preparing for the release of the software product. And fourth type is user satisfaction test. Here, this is one of the user acceptance kind of test. That is, in this test, it is checked that user satisfies with the measurable parameters or not, such as like cost, product functionality. That is user satisfaction test. So this is all about acceptance test having four types: configuration review, alpha testing, beta testing, and user satisfaction test. Now, see the comparison between that alpha and beta testing. So here alpha testing is performed by the developers in virtual environment and beta testing is performed by the customers in live environment. Then here alpha testing involves both the white box and black box testing. As it is at the developer side, it involves both the white box and black box testing. And beta testing commonly uses black box testing. Okay, then alpha testing is performed at the developer side and beta testing is performed at the end user of the product. Then sometimes it is also performed by the independent testing team. Alpha testing sometimes it is also performed by the independent testing team. And beta testing, since it is performed on the customer side in live environment, it is also called as live testing. So alpha testing is not open to the market and the public, and beta testing always open to the market and public. Alpha testing requires a testing environment or a lab. Here, beta testing doesn't require a testing environment or a lab. Alpha testing may require long execution cycle because it is as developer side. So it requires long execution cycle. Beta testing requires only few weeks of execution that the end user is going to check the that system is going to perform based on the requirements or not. He is satisfied with the product or not. Then here in alpha testing, developers can immediately address the critical issue or fixes in alpha testing. If the developer finds any errors or any critical issue at that time or at the while at alpha testing, finds that error, it will or the developer fixes that errors in that alpha testing. And in beta testing, most of the issues or feedback collected from the beta testing will be implemented in future version of the product. This is the comparison between the alpha testing and beta testing. The next type of testing is system testing. Here, system testing is conducted to ensure the proper working based on the factors. That factors are performance of the system, that we are a system we are going to test here based on the parameters or some factors are there. Based on that we are going to perform the system testing. That parameters are performance of the system, that system is going to how the system is going to perform based on the inputs. Then stress and load control of the system. how that system is able to handle the load, then security of the system, that system is, we have developed that system is secure or not, then user friendliness, that GUI of that system, then reliability, that is recoverability of the errors, then flexibility and maintainability of the software, how the software is flexible with the environment, and it is easy to maintain or not, that is system testing. Then there are some types of system testing is there, that is the recovery test, security test, stress test, and performance test. So these are the types of system testing. So your recovery test means we have to determine how fast the system recovers from the fault. If we are having any fault with the system, that recovery test, in that test we are going to determine how that system is going to recover from that faults. Then security test, so it ensures that the system data is protected from unauthorized access like fraudsters, hackers. That is the security test. And third one is stress test. That is, it tests the reliability of the system. And last one is performance test. It tests the runtime performance of the system to find out how fast the system performs under a particular stress or load. So your system testing is performed in terms of inputs and outputs of the system. We are going to provide some inputs to the system and we are going to check that system with the outputs that we are going to get. Then system testing is also called as thread testing in case of object oriented testing. Here system testing is used to test the result of a system level input, an interleave sequence of system inputs and outputs, then the sequence of transitions in the system, recovery, stress, and performance factors of the software as in the traditional software. These are that system testing is used for the test here. The tests are that result of that system based on the level of input, then recovery of that or the reliability of that system, and the stress and performance factors of that software, then the sequence of transitions in the system. Yeah. Then the next type of testing is stress testing. Here, this stress testing is a non-functional testing technique. It is a non-functional testing technique that is performed as a part of performance testing. Per- Stress testing is a part of performance testing. So during stress testing, the system is monitored after subjecting the system to overload to ensure that the system can sustain the stress. The system is able to handle that stress or not. That if we are giving the inputs or many inputs or the fraudulent inputs to the system is able to handle that stress or not. Then the recovery of the system from such phase after its stress is very critical, as it is highly like to happen in production environment. That is stress testing. That is non-functional testing technique. That is, through stress testing we are going to check the performance of the system. Then next type is load or volume testing. So here load testing is performed. It is a performance testing technique using which the response of the system is measured. Performance of the system is measured under various load conditions. So the load testing is performed for normal and peak load conditions. So there are some objectives of load testing. That is the response time. We are going to check the response time after the load testing, then throughput of the system, then resource utilization, maximum user load, then business related metrics. So these are the objectives of the load testing. And next is orthogonal testing. Here orthogonal testing is also called as orthogonal array testing. So the testing is a systematic and statistical way of a black box testing. This technique is used when number of inputs to the application under test is small but too complex for an exhaustive testing. If you are providing inputs to the system is small, that means if we are going to provide what we can say, if we are going to provide the limited number of inputs, that system is expected many more, that time it is complex for an exhaustive testing. Here there are some characteristics of orthogonal array testing is there, like it is a systematic and statistical approach to pairwise interaction. Executing a well defined and a precise test is likely to uncover most of the defects. So here it is 100% orthogonal array testing implies 100% pairwise testing. Then the last point from the chapter number 9 is interclass interclass test case design. So generally testing in the object oriented application is for maintaining quality and correctness of the software. So there are some parameters or some testing parameters are there for the object oriented analysis and design model. Like these parameters are like correctness of the object oriented analysis and object oriented design models. Correctness, then consistency, and third parameter is test various phases like analysis phase, application analysis, architecture design, and detail design. So these are the parameters for testing the object oriented analysis and design model. So that's it for today's session. We will stop here. We have finished with the chapter number 9. Thank you.